And yeah, there we start. The triangle again, if you do not remember the triangle, I want you to draw it out. Draw it on the top, or if you need paper, here is the paper. If you have a notebook, write it on your notebook. Yeah. So first thing to do is your 30 degree, 60 degree triangle. So for 30, 60 degree triangle, what you do is start with a right equilateral triangle. And the triangle is side 2, right? So you have a 2, you have a 2, and you have a 2. But I'm not going to write a 2 in here because I'm going to cut into right in the middle. So I'm going to cut right in the middle. That means this side in here is going to be 1. Is that right? Now I'm going to cut off the other side of the triangle. Get rid of this side. Just thinking of it on the half of the triangle. Because it comes from equilateral, that means the triangle itself is, what is this angle? Equilateral triangle. So that's 60, it has to be 60. Yeah, and because this is a 90, therefore this one is a 30 in here. So after we having that, the next thing we are going to do is Pythagoras theorem. 2, 1, and this is going to be root 3. Yeah, and that is your very first triangle. Second triangle is 45 degree. So you come from a square. Again, cut it into half. So if I cut it into half, it will be looking like this, and this is my right angle. And that means this angle in here is going to be 45, and 45, this is 1, 1, that is a root 2 by Pythagoras theorem. Okay, so I need you to remember these two triangles by heart. Put it in your head and remember it. Then we are going to look at a bit more than that. Therefore, if I ask you what is sine 30 degree, you're able to answer me. Sine 30 equal to opposite over hypotenuse. That means 1 over 2. Is that right? And remember 3 more terms that we learned, which is going to be cos. We have cos. Okay, cos 30 degree. Okay, if you want to, let's write the whole list up. Cos 30 equal to root 3 on 2. Sine 30 equal to 1 on 2. And then tan 30 equal to root 3, or 1 on root 3. Yeah. And, okay, if you want to write, you can write in here. Okay, you already start writing that. That's okay. Right. Then, having 30, the next one is 60, right? So, let's work it out as well. Cos 60 equal to a half. If you haven't memorizing all of this, I need you to remember just like how you remember your timetable. Make sure it's all in your head. Good, you have all that, and here the 45? Yes, you do. Okay, then 3 more rules that is going to come along is the cosec. What is the meaning of cosec? If I ask you what is cosec x, what you do, you write it as 1 over, look at the third letter, which is s. So that means 1 over sine x. Yeah, always look at the third letter of it. Yeah, because of the s. And if I ask you what is sec x, what you do is that you write it as 1 over, the third letter is a c. That means it is cos x. And the last one is cot. 1 over 10. So Trigo is a lot of rules. You have to remember them by heart. If you don't, that means you weren't able to work it out. Cosec. If you start on what is cosec, that means you weren't able to continue. Is that right? Yeah, just memorizing it at this stage. Okay, these are something that we looked at before, and now we have something new. Let's look at the, okay, have you written? Yep, let you finish with writing it first. If I'm looking at the number I have on the black and the blue, let's see. Cos 30, which is root 3 on 2. For here, root 3 on 2, that means I'm using 60 degree. When you add up the 30 to 60, what do you get? 90. Okay, so when you have 30 and the 60, you add up to 90, that means the side in here, the value you get should be the same. See whether it works that way. If this is a 30, let's find a 60. Yeah, they are the same. When you have sine to cos, if these two angles add up to 90, that means the value you get should be the same. Right, 45 plus 45 is 90. Look at these two values, they are having the same. So what we can conclude from this here is that when I say sine 90 minus x should equal to cos x, isn't it? Let's think about sine 90 minus 30. 90 minus 30 is 60, right? Sine 60 equal to cos 30. That's what we have. So this is another set rule I want you to remember, which is sine. If I have the cos, we also know it's going to work the same way, equal to sine x. That's the first set. Not only sine and cos interchangeable, I call them interchangeable. And the other set that is possible will be if you have 1 over sine. 1 over sine means cosec, isn't it? So I can write cosec 90 minus x equal to sec x. The other way around. And the last one. Okay, now knowing all of this, I want you to look at your very first column of your first page. The first question I want you to find out what is 2 times 60. That means 2 times 10 60. What is 1030? What is 1030 going to give you? That means it's 1 over root 3. That means you are going to do 2 times 1 over root 3. And you are going to get that. That's good. And cosec. How can you write cosec? 1 over sine, yep, 45. Yep, that's what you do. And what is sine 45 going to give you? Good, then times it together, and yep, and that will do. Move on to the next questions under. Yep, going down the column. Yes. Yes, put it on the side. Look at the third letter. Which is S times 1 over sine. Yes. That's right. And what's sine 45 going to give you? going to write as 1 over. What is the third letter here? S, right? So 1 over sine. Sine starts with S. Yes, you always look at the third letter. Yeah. Right. Okay, we arrange that one. Yeah. Okay, for question C, I'm going to write off the top bit. You all write this down already, right? Okay, 1e, right? Is that 1e? Which is you have cosec 45. So you are going to write 1 over sine 45. And from what we know, sine 45 is 1 over root 2. Now, I want you to think about this line. Yeah, everyone can you look in here? This line in here is a divide. Okay, that line is a divide. So I'm going to write it as, think about or write it 1 divided by 1 on root 2. Okay, remember in your early age of the divisions, if I have 2/3 divided by 4 over 9, what will you do? You are going to write 2/3 times it by 9 over 4. Is that right? You're going to apply the same idea in here. I'm going to times it by root 2 on 1. And that is going to give you equal to root 2. Whenever you have fractions on top of the other fractions, I want you to think about the fraction as a divide. And then flip the second terms upside down as you go, after you change it to a times. Alright, yeah, you're going to have that a lot. Good. And then, yeah, what's 1060 going to give you? Oh, no, 1060. I think you're looking at the wrong one. 1060 is, you see? Okay, so to start with, I'm going to write as what you did in here. So 1 over root 3, and that's done. And you don't have to do anything for these questions because it's not fractions on fractions. Yeah? Good. Yeah, cosec, you can write as 1 over, what's the third letter? Yeah. Next question I. Is that sine? What's the angle or true?
So, yeah,
45. Okay. Right. For this question, question 1I, you have 1 over sec 45. Sec is, I can write as 1 over, sec itself is 1 over cos 45. Is that alright? Yep. And now I'm treating this one as a over, which is divide. Now this is my divide one, this one. So whenever I have fractions, I try to get rid of fractions on fractions first. So I'm going to have it as 1 divided by 1 over cos 45. Is that right? That means 1 times it by cos 45 on 1. Is that right? Yeah, because divide into times, I flip them upside down, so it's over 1. Now, all of these times it is literally equal to cos 45. Cos 45, you know, is 1 over root 2. Yes, that's the way. Okay, wait a second. The 10 first. 1045 give you 1 on the top. Yes, you're right. Good. Okay, I think we got the wrong one. This is no root 2. It's just a 2. Okay, this one. Sine 60 is root 3 on 2. Yes. Yeah. Come forward. And then 10:45 degree. Side 45. Okay, are you all good? Get a hang of it? Right, I want to try the second column as your homework. Now I want to turn to the next page. Right, so when you turn to the next page, it's just another bunch of stuff that you never see. So now I want you to draw another right angle triangle again. Okay, so you do not need to draw the right angle triangle. If you look at question 1, just looking at quick question 1, if you're looking at the top, can you remember what rules are we going to? Just the top. You have it as cos 90 minus x. What should that be? How can you write cos 90 minus x? Remember the rules that I write right in here? There are 6 of them. Which is this one. Yeah, do you have it here? Yeah, that one. So cos 90 minus x, you can write as sin x. Is that right? That's what you have. But I did not give you the rules for the one on the bottom, which is cos 360 minus x. Okay, so this is what I want you to draw. I want you to have a paper or on your notes. Draw a big number plane, which is looking like this. Okay, we are going to put in a lot of information in here. Okay, this is a big number plane. We are going to fill in a lot of things on here, on this 4 quadrant, and make sure you fill them right. Yeah, a big number plane. Okay, in Trigo, my number plane, of course, is not like 1, 2, 3, 4, 5, like what I have with a normal coordinate geometry number plane. In here, it's all about angle. The first angle I have will be the 0 degree, which is right on the east, if you want to, as a compass. There's your east. This is your 0 degree. And the angle is going from here, it goes counterclockwise. It goes that way. Okay, so that means this will be 90 degree because you go here to there 90. And then that means this angle in here is going to be 180, add another 90, add another 90, 360. I can keep adding this. So 360, if I keep another 80, 90, that means I add to the angle. But I'm going to stop at 0 to 360 now. Oh, good? Yeah. Now, if I am looking at the angle, so if I draw a triangle, the triangle is going to look like this, isn't it? Yeah, in here, have you been working on A, S, T, C? Have you looked at these 4 quadrants at school? Yes, yes. What is the A represent?
It's like for a whole sign.
Yes, all the sign is going to be positive in here. S means sine is positive, tan is positive, and cos is positive. And the angle on this quadrant in here, I'm going to call it as angle theta. And the second quadrant is going to go this way, isn't it? Going to go this way. So the angle is going to be 180. I'm going to use 180 minus theta. And this quadrant in here from 180 to 270 is going to 180 plus, and the last one is 360 minus. Right, from what you just told me, the S means sine is positive. Is that correct? So that means when I write it out, if I write sine 180 minus, that means you can write as sine theta because sine is positive. From a bulky term, you make it into a simple term. If I ask you what is cos, 180 minus the angle, you are going to give me cos in this quadrant is negative, right? So your answer is going to be negative cos. And same with the tan. In this quadrant, is going to be positive or negative in here? Tan. Negative. So you are going to write negative tan theta. Does it make sense? Who is positive in here? Tan. So that means if I write sine 180 plus, I'm going to get a negative. I write as negative sign. All good? Yeah, and I want to fill them all up in here. So if you have cos 180 plus, is going to be negative as well. The only one that is positive is a tan. That's what I mean. Okay, just be looking at the two number in here. I use 180 minus, I use 180 plus. The only number I never use actually is 270. You are not using 270, you are not using 90. Whenever you see the 90, we are going to use the other set of rule, remember, which is sine 90 minus x equal to cos x. We change sine to cos. This one, you do not change the 10, keep it as a 10. And then the last one is going to be the same. It's going to repeat all over again. The cos is negative, the rest is positive. The cos is positive, the rest is negative. Any questions so far? No? Okay, now if you look at page 2 now, I want to simplify. So looking at the first questions, we are going to do it term by term. What your job is, get all those bulky 180 minus, 180 plus, 90 minus, or 360 minus away. Make it into just x. So the first question I ask myself on the top is cos 90 minus x. Which rules am I going to change it to? Cos 90 minus x, that means I'm using the 90, the one that we have earlier, isn't it? Yeah? So the question you have will be cos 90 minus x over, what's the bottom?
Cos 30, 360 minus.
Cos 360. Yeah. The top, I'm going to change it to sine x, because what we have on the rules, right? Cos 90. The bottom is cos 360. 360 is in the C. That means cos is positive. Look at this. Cos 360 equal to cos theta. So it's equal to cos x. Oh, one more term. Sine over cos equal to tan x. So I did not write it down. So maybe you want to write it somewhere. Tan x, you can write as sine x over cos x. This is something we use quite often. And then also cot x equal to 1 on tan x. And it's also equal to cot x. I can write as cos x over sine x. Yeah, this is method 3. you can write as a, because sine over cos equal to 10, so it's equal to 10x. Okay, so for page 2, I want to try every second questions. Go down every second questions. The other one that you miss out, you try as a homework. So the next question I want you to try will be question C. Okay, if you look at question C, sine 180 minus x, you can write it as sine x, isn't it? Good. And then the other one next to it, that means if there's no sign in between them, that means it's a times it. 10 90 minus x, that means you're looking at the 90 rule, which is 10 90 minus x equal to, what is it equal to? Cot x. Good, good. And cot, from there, from the green, cot you can write as cos over sine. Yeah, then we change it again. You are going to have sine x times it by cos x over sine x. Yeah, cot is equal to cos over sine. So you.
Are these both cot x?
Sorry.
Are these both cot x?
Oh no, this one is a tan x. Oh, these two. Yes, cot x. You can write in two different forms. In here, I'm going to pick this one because I have a sign in here. So you need to also choose which one is better. Okay, then you can cross out. Sorry, the sign with the sign. Yeah, cross out the sign with the sign. Yeah, and that will give you equal to cos x. Done. All right, good. Let's go to question E. Okay, the first term minus sine x. Minus sine x, I can't do anything. I will rewriting it. I'm going to write minus sine x. And then times it by sine 180 plus x. What would that be? 180 plus on the third quadrant is going to be in tan property. So that means it's negative sine x. And then minus cos x, I can't do much again. Yeah. And cos 180 minus, that will give you minus cos x again, isn't it? So just be really careful with this one when you are writing it. Because of the minus, make sure you know the minus is a times in between. So you are going to have minus sine x times it by minus sine x, right? And minus cos x times it by minus cos x. Yeah, make sure you know this is a minus cos x, not negative. It's a negative cos x, it's not a minus cos x. Yeah, so this one minus times minus will give you a plus, and sine times sine is supposed to be sine x squared, right? But in Trigo, we don't normally write like that. I'm going to write as sine square x. That's how you write it in Trigo. These two terms, they are the same thing, but this is how you write it. This is a formal way of writing it. And negative times negative, again, is a positive. Cos times cos is cos x squared, but I write as cos square x. So, and nothing else I can do at the moment, it's just that. This will be a plus because negative times negative? Yes. Okay. Yeah. Okay, then we go to the last one, which is question G. Cos 180 minus x. Is that a positive or negative for cos 180 minus x? Negative because it's at the s. S, that means cos is going to be negative. Right, then you have the over sec 90 minus x. Sec, you can write it as 90 minus x. Can change it to cosec, right? And then tan 360 minus x, that means I can write as tan negative 10x. we are going to change more because cosec, the third letter is S, I can write as 1 over sine. And tan, I know I can write it as sine over cos, which is the one on the top. So now what I can do is minus cos x. This term, I can write 1 over sine x. And tan, I can write minus sine x over cos x. Then I'm going to cross out as much as I can. The sine and the sine, of course, I can cross it. And negative times negative or negative divided by negative become positive. So what I end up is, I have a fractions. The top of the fractions is cos x. The bottom of the fraction is 1 over cos x. Just be really careful, make sure you keep the 1 because 1 times 1 is still a 1. Then we treat this one as a divide and then we do the timesing, swap it around. So you're going to cos x times it by cos x on 1. So if you do the swapping and dividing become the timesing, you are going to eventually get the cos square x. Everything good? Yeah. Now, then the next page is really similar, except this is proving. So when you are proof, if you have a word of proof or show, if you saw those two words, proof or show, what you need to do, you need to start your answer by saying left hand side equal to something, 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 eventually is equal to right hand side. That's what you should have. Or you can start with right hand side equal to, keep going, simplifying it, then eventually you get to left hand side. So which side are you going to start is the complex side of the equations. By looking at the question 3 then, which side look bulky and big where you can reduce it? Is it the left or the right? Left, so much bigger, isn't it? So your job is to start with left hand side. And when you write out the LHS, copy down the question straight after that. So how you write it is going to be left hand side. I just copy down the whole thing. Yeah, this is what I have on my left hand side. Then we are going to simplify term by term. And what you want to get at the end is cot x. My really last step in here should be cot x. And then this is equal to my right hand side. This is something I'm going to fill up in here. Alright? Yeah. Sine 180. Which quadrant? Positive or negative? 180 plus. That means pop. That is 180 minus.
Oh,
Yes, negative. This is the third one. So it's going to be negative sine x. And 10 interchange with who? 10 change to cot. Times it by cot x. And sec, you can write it as cosec, right? Okay, so we don't have bulky term anymore. That's the first step to do. Get rid of all the bulky term. Then we are going to use our properties of what we know about cot. Sine is the simplest term. I can't do anything. So I'm going to revising it. And the cot. I'm thinking, should I change it to cos over sine? But final answer have a chord. So I might just keep this one. See whether is this one actually is the one that stays. So I will just keep it. And cosec, you can write as, what is the third letter? S. That means it must be 1 over sine. Okay, we have that. That means timesing means you can cross out if you can. So this thing is over 1, that is over 1. Top and bottom can cross if you have them the same. Yes, I do. I have it there and there. Yes, my answer is minus cot x. Yeah. Can you change your answer on the right hand side to minus cot x? I forgot to change it. Yeah. At the beginning of the questions, on the question, can you change the right hand side to minus cot x? Otherwise, I'm not going to be having it right. So, a form is equal to right hand side. And that's the end of it. Make sense? Yeah. So whenever you are proving, the proving part, you always need to start with left or start with right. And you end with left or end with right. You have to go step by step and always keep an eye what is the terms that you want to end with. That's why I don't change my chord, because that is already there. All good? Right. Okay, question 4. Can you try it as a homework when you get home? Yes, start with the, I suppose you are going to start with left hand side as well, because it's a big terms, isn't it? Right, now let's look at question 5. You were given sine x equal to a on b. When you are given sine x, cos x, cot x, or cosec x, whatever that is, equal to something, the first thing I want you to think of is triangle. So if you have sine x equal to a on b, can you label the a on b on a right angle triangle? So first step, draw out a right angle triangle. This, because it's in the first quadrant, the x is between 0 and 90. So I'm going to draw my right angle triangle in the first quadrant with angle x in here. So if you're thinking of the number plane we had earlier, actually this is what my number plane is. Yeah, it looks like that. I'm in the first quadrant. This is my x. Can you picture that? The big crossing that you draw out. And you have it as a over b. Sine is opposite over hypotenuse. That's what I have, a over b. And a lot of students will start telling me that that side is going to be c. No, you're not going to write as c. That side is Pythagoras theorem. That will become square root of b squared minus a squared. So let's write it as c squared minus a squared. Okay, having that triangle, I suppose you can answer the rest of the questions. I want you to express 10x in terms of a and b. 10x, 10 is opposite over adjacent. So you can answer the questions. 10x equal to opposite over adjacent. And that is it. Okay, your quadrant. You are drawing on the wrong quadrant. Yes, you should be drawing on this quadrant.
Yeah.
But that's okay. Then we get rid of the quadrant. Think of it. This is just our x. Yeah. Otherwise, it will look confused, right?
Yeah.
Yeah. Okay. And the second question is sec x. Is 1 over cos x, is right? And cos x is adjacent over hypotenuse. So you are going to have 1 over adjacent over hypotenuse. And we know this is your divide. This line is your divide, and you do the divide and then you change it to a times. Eventually, you're going to get b over root b squared minus a squared. Any questions so far? Yes.
What's like the B, like on top of the B?
Oh, this one, this is 2 1 here. This one is n here,
Oh.
and then this one is on the bottom. Yes, yes. Mm. And then question B is a proof again. Proof, that means you start with left hand side. Hopefully we end at right hand side. Okay, because the left hand side look bigger for me. Yeah, it's going to be sec squared x minus 1. So I'm going to start with left hand side. Left hand side equal to sec squared x minus 1. And sec squared x, I already know sec x is this one. When I'm squaring it, that means I square this whole term. What I need to do, because the question says sec square x, that means I'm going to square this thing. Is that right? Because I'm squaring it, that means I need to square this term. So if I square this term, I'm going to get b squared. And square root and square, they cross one another off, right? You balance it out. So I'm going to get b squared over b squared minus a squared and then minus 1. Is that okay so far? Then, of course, I have two terms. If I want you to do 2 on 5 minus 1. Of course, the next step you are going to do is 2 on 5 minus 5 on 5. Is that right? Then you can do the minusing. I'm going to do the same with that one. So I'm going to have it as b squared on b squared minus a squared minus 5 on 5, which is 1. b squared minus a squared on here. So there's a 1. And now I have common denominator, I have the LCM, then I can minus the top. So that will give me equal to b squared minus b squared, that means no more b squared. Minus and minus become plus. So we are going to have a squared over b squared minus a squared. Are you alright? Audrey?
The 2 on 5.
Oh no, this is example. This is just example. This is just like if I have 2 on 5 minus 1, just like think of it, this if this is 2 on 5 minus 1, I need to change this to 5 on 5. That means I change this term. Yeah, they come from nowhere. Yes. Oh good? Yeah. And then we're going to continue from there. And what do we want to prove? We want to prove it is equal to 10 square x. Look at the 10. 10 is looking like this. Almost there, isn't it? So I'm going to kind of like cheat it. So it looks like this. So I know if I have a 10, that will be a over root b squared minus a squared. That will be that one squared, right? If I pull out the square, that will be a squared. Square root and square, they cross one another. So I'm going to be 10 square x. So as what I say is, always keep an eye on what you want to achieve. So you're so close to it, you need a square. That means you might want to square this on the side and see what it could look like. So if you're squaring it, you're going to see, it's equal to this one. All good? Yeah. Yes?
We get from here to oh no.
Here to there?
Oh no, here to
there.
here.
Okay, so b squared minus b squared, that means no more b squared. And then minus and minus become a plus. So that means nothing multiply by a squared. That's why I get an a squared in here.
Oh, okay.
Yes, I can write it, okay, if you
Yeah.
want to, I can write one more step, which is here, b squared minus a squared. If I combine the whole top, b squared minus b squared plus a squared.
Wait, why is it plus a squared?
Ah, because this is a bracket in here, that is a negative. Negative times positive, I get a
Okay.
negative. Negative times negative, I get a positive. Yes. Okay. And for question 6. Question 6 is all about, you can do that in year 9 already from last year. So first thing, look at the questions. It's right angle triangle, isn't it? Right. So if you have the angle 60, I said I want you to try to work it out using exact value. So if you look at the triangle, it looks like that, the first one. This is a 60 degree, this is an 8, this is an x. So first step is from the angle, we know this angle. This is the opposite, this is the hypotenuse. So what am I going to use? Sine, cos, or tan? Sine, yeah. I'm going to write that. Sine 60 equals to opposite over hypotenuse. And from the triangle we learned earlier today, we know earlier today, remember the sine 60 triangle, the 60-degree triangle? What is sine 60 going to give you? Yes, that's what you're going to do. Change this one away, make it root 3 on 2 equal to x on 8. Okay? If you want, we learn it from the sine rule. Whenever you have an unknown, this is your unknown, this is an 8. If I want unknown by itself, I times the 8 over, isn't it? The sine rule? Yeah, now I times the 8 over. So that means x equal to 8 root 3 on 2. And of course, I can cross the 2 and the 8, 4. So therefore, x equal to 4 root 3. Does it make sense? Yeah. Okay, question B I want to try as a homework because it's going to be similar. Let's jump to question C. Question C, you have 2 triangles joined together. Triangle, we always, just like when you do apply your sine rule and cosine rule, we always look at the triangle that have the most information. Which triangle? Is a small triangle have more info, or the big triangle, the big one, or the small one? That we are going to start with. Big one, I agree. Yeah, because big one, I have an angle, I have a side, I only have one unknown. So what am I going to use? Sine, cos, or tan? This is your cos, because this is your adjacent, this is your hypotenuse. So write it down straight away. Cos 30 degree equals adjacent over hypotenuse. And you know cos 30 is going to be? Yes, root 3 over 2 equal to x on 16. Yep, if you want to find the x times the 16 to the left hand side. So you are going to have 16 root 3 on 2 equal to x. And therefore cross it out. So you are going to have 8 root 3 equal to x. Okay, as what we do with the sine rule, cosine rule, we put the number in as soon as you find out. I'm going to put an 8 root 3 in here. Now, the small triangle, not very friendly at all because I don't have any side. Were we able to find some side? Yes, I think we do. This one, is that right? How can I find out that side? Yes, I will use that because it's a right angle triangle, Pythagoras theorem. Let's call this as an A. Yeah. So your A square is going to be 16 square minus 8 root 3 square. And what is 16 square going to give you? I have no idea. So let's put this lot into the calculator and see what we can get out of it. So we have 16 square. You get 64. And therefore A equal to square root of 64 is going to give you 8. In here, I'm not going to worry about the negative because 8 is the length, it's never be negative. Yep. A equal to 8. Were you able to find out y now? We have adjacent, we have hypotenuse, that means we are going to use cos. Yes, of course. Yeah, so you are going to write cos 45 equal to y over 8. And cos 45 from the triangle you know is 1 over root 2 equal to y over 8 times the 8 over 8 on root 2 equal to y. And in here I know I can rationalize the denominator, I might do that. So times root 2 to the numerator and times it to the denominator. So I'm going to 8 root 2 on 2 equal to y. Cross out the 2 and the 8, so y equal to 4 root 2. So it doesn't matter how many triangle, where is the triangle, just make sure you focus on the triangle that is the most information. That is the first one you do. That is a triangle. And then you, whatever you find out, make sure you put them into the diagram so your eyes recognize it, your brain recognize it. All good? Right. Then question D, I want to try as your homework again. And I'm going to move you to question 7. Question 7, I give you, remember the one of the question earlier, which is questions, I give you sine x equal to A on B. Yeah, this one is the same type, but I give you in terms of horrible number. I give you cot 90 minus x. What can you write instead of cot 90 minus x? You can write as, yeah, so that is your very first step. Get rid of it and change it to 10x equal to 1 on 2. And step 2, what do we need to do when I know 10x equal to 1 on 2? Draw a right angle triangle and label it. Yes, that's the first thing to do. Change it away into something we recognize. Draw your right angle triangle. So whenever you have sine x, cos x, 10x, always draw a right angle triangle and label it.
What is that? Like
That means the x is between 0 and 90 degrees. That means it's in the first quadrant.
Okay.
Yeah, it doesn't mean much. It just covers itself. It just means it will not be in the third quadrant. It will be only in the first quadrant.
Okay.
Yeah. For year 10, actually, most of them is either in the first or the second quadrant. They are not learning third and fourth at all. That's all extra. Yeah. Okay. Yes, for the year 10 syllabus, you are learning the first and the second, but it's like if you are going to do year 11, it's going to third and fourth. That's why everything in there. All right, yeah. Okay, good. Therefore, by looking at year 1 and 2, what is this side going to be? How do you find out the third side? It's a right angle triangle. How do you find the third side? You use... Yes, of course, of course. Okay, find out the Pythagoras theorem. that number. Yeah. Yes.
Go from here.
Okay. So what is your sine x? You know sine x is 1 on root 5. And tan x is, yeah, sub the number in. Okay, are you up to that question with sine x equal to tan x? Yeah? No, not yet, not yet. Okay, so are you doing the question C?
No.
No.
Wait,
Yeah.
wouldn't it just be like sin x is 1 and
Sine
then
x.
cos x is 2?
What do you? Oh no, you can't say that. No, because I have 1 and 2 in here, so that means this term in here, Pythagoras theorem, is going to be 2 squared plus 1 squared, which is going to be 5. So that means sine x is going to be 1 on root 5. Yeah. Even though tan x, I know where you come from. You're thinking of tan x with the sine on cos. That means the sine x must be the 1. No, you can't do that. Okay? Yeah. Okay, so therefore sine x is equal to, okay, you know this number. Let's put in the root 5 there. Therefore, sine x is going to be opposite over hypotenuse. That will give you 1 over root 5. So your sine x is 1 over root 5. Is that right? Sine x is 1 on root 5. And then the next question is, what's the next one I ask you? Cos x? Cos x, just working from this triangle. Cos x is going to be 2 over root 5. And then question C, which is cos 90 minus x over 10x. Now, I need to use what you learned earlier today. Cos 90 minus x becomes sin x. And this is a 10x. Right? And sin x I know is 1 over root 5. I'm going to sub in the number. Over 10x is 1 on 2. So that means going to be 1 over root 5 divided by 1 on 2. That means times it by 2 on 1. So it's going to be 2 over root 5. Oh, good. And similar with the next questions. Okay, your homework for today, I want you to complete until page 4. Okay, leave out the page 5 because I haven't shown you how to do it. And the biggest homework for today is memorizing what you've written down today. Okay, you need to have those informations in your head as soon as you can. Okay, don't drag it. Just get the triangle in and then get the ASTC and who is negative, who is positive, and then the last one is the 90 degree. Yeah,